Okay, good evening, everyone, and welcome to Environmental Coffee House. I'm your host, who will be in the background tonight, Sandy Schoelles. Oops, and I just want to say that I am very happy to have Jennifer and Nicholas and Jim and Tony here tonight. So I'm going to turn it over to Jennifer, but I just wanted to say hi, and I'll see you at the end. Mwah.
Hey, thank you so much, Sandy. It's always good to see our little Jiminy Cricket up in the corner there. So, hello, Antonia, Jim, and Nick. Hope you guys are all doing great tonight.
Yeah, doing okay.
All
Yeah,
right.
yeah, doing good.
All
Hanging out.
right. Yeah, hanging out. And we made it through 2023, which is kind of amazing. So, we have a lot of material to cover tonight, and it's going to be kind of freeform, except for this very first part. I'm just going to take a little read through this article from the New York Times that just came out, and it says Earth was due for another year of record warmth, but this warm? Scientists are already busy trying to understand whether 2023's off the charts heat is a sign that global warming is accelerating. I don't know. What do you think? What do you think, guys? Do you think global warming's accelerating? Tell me.
Yeah,
Possibly.
probably. Yeah.
I would say yes.
And we would say
Yeah.
yes.
Yeah.
Yeah. So we're going to be showing a lot of graphs tonight, and they all have something in common in that they are going up with no sign of stopping. So I'm just going to run through this quick to kind of get us in the mood. Earth is finishing up its warmest year in the past 174 years, and very likely the past 125,000. Unyielding heat waves broiled Phoenix and Argentina. Wildfires ranged across Canada. Flooding in Libya killed thousands. Wintertime ice cover in the dark seas around Antarctica was at unprecedented lows. This year's global temperatures did not just beat prior records, they left them in the dust. From June through November, the mercury spent month after month soaring off the charts. December's temperatures have largely remained above normal. Much of the northeastern United States is experiencing spring like conditions this week. That is why scientists are already sifting through the evidence from oceans, volcanic eruptions, and even pollution from cargo ships to see whether this year might reveal something new about the climate and what we are doing to it. One hypothesis, perhaps the most troubling, is that the planet's warming is accelerating, that the effects of climate change are barreling our way more quickly than before. What we're looking for really is a bunch of corroborating evidence that all points in the same direction, said Chris Smith, climate scientist at University of Leeds. Then we're looking for causality, and that will be really interesting. As extreme as this year's temperatures were, they did not catch the researchers off guard. Scientists' computational models offer a range of projected temperatures, and 2023's heat is still broadly within range, albeit on the high end. I'd say it's on the high end. So, for much of the past 174 years, humans have been filling the skies with both greenhouse gases and aerosols, or tiny particles, from smokestacks, tailpipes, and other sources. These particles are harmful to the lungs when inhaled, but in the atmosphere, they reflect solar radiation, partly offsetting the heat trapping effect of carbon dioxide. In recent decades, however, governments have been reducing aerosol pollution for public health reasons. This has already caused temperature increases to speed up since the 2000s. Wow. And in the much discussed report last month, the climate researcher James Hansen argued that scientists had vastly underestimated how much the planet would warm in the coming decades if nations cleaned up aerosols without cutting carbon emissions. So that is basically pertaining to, I think that's pretty much all I'm going to read because it kind of, you get the general picture. It goes on and on, kind of like that. But that's pretty interesting, right? Because they cut the sulfur out of the fuel. Who knows about that? Jim, do you know about that and what it's done to the climate, taking the ship fuel and cutting the sulfur out of it so there's not so much sulfur dioxide coming out? Do you know about that?
Well, what those who study this, their, um, I guess you could say, hypothesis or their assertion is that with the reduction in sulfur aerosols, that there's less cloud formation, therefore more solar energy is reaching the surface, thereby warming the the surface of the oceans. We see this most pronounced in the North Pacific, where a lot of the cargo shipping, great bulk of the cargo shipping takes place across the North Pacific. So their contention is that, and they're saying this is leading to contributing greatly to the Earth's energy imbalance. Um, that's part of the story because, in my view, just saying the Earth energy imbalance explains everything is not accurate. It's only part of the story. It's not the complete story. Um, my other issues with the DEI folks is that they only really consider the TOA the top of the atmosphere, and and they say, oh, this radiation comes in, that radiation goes out, and there's an imbalance. They're not taking into account the oceans. We'll talk more about that later. But
Mhm.
in my view, because the oceans have been absorbing so much the energy, that's is an energy imbalance, and it's just we are now seeing the energy in the oceans returning to the atmosphere. And yeah, we've had one hell of a year.
One hell of a year. And guys, I'd like to draw your attention to this graphic that we've got up here on the screen. This is from the NYT article. And you see that thing where it's got a little rectangle there, kind of just in the middle, a little bit over to the right. That's just to demonstrate that 1 year, exactly, 1 year is basically a line. And you can see the legend is really hard to see. In fact, it's at the top, and I don't think you can see it in this picture. But basically, this graph goes from 1850 to 2023. So it's quite a bit of time, and you can see 2023. Each one of those red dots right over on the right hand side, those are all record setting months. So between, I think that's like 2020 and 2023, those were on all the records, the latest records. And it's 2023 is not like the other years. It's really got liftoff. And like to reach out to Tony and Nick and say, what do you see here? And what do you think about 2023, where we're going?
I mean, for me, for me, it's just like a big spike. I mean, 2023 is just really extraordinary to see what happened with the atmosphere, what happened with the oceans in particular, and the warming of the oceans and the return of the heat from the oceans to the atmosphere. I mean, you had all this talk about El Nino and the heating of the caused by El Nino, but you saw all these heat anomalies throughout the Mediterranean, northern Pacific, and North Atlantic, and all these other regions of the world um, throughout throughout 2023, and it was quite incredible to see, and heat waves on land that resulted as well from um, Yeah, it was 2023 was quite the year, and I mean, even going into excuse excuse me, going into winter, we've had here in Fargo, North Dakota, where I am, a very mild winter. The National Weather Service is saying that Fargo might looks to have the warmest December on record here in Fargo, North Dakota, where we're not going to have end up having a day below zero here. Like usually we have temperatures below zero, and we're not going to have had a temperature below zero to end the month of December at all. It's going to be a record setting month where we haven't had a temperature below zero this season, um, uh, which is very, very strange.
Mm.
Um, so it's very warm, and we had actually had an ice storm on Christmas Eve, where we had branches come down and some power loss in parts of eastern North Dakota because of ice accumulation. Um, because it was cold near the surface, but it was warm aloft, and so you had snow fall, melt, and then refreeze before it hit the ground, and so you had rain that refroze on contact, and you had ice accumulation and on everything, and all that warm air aloft, and instead of cold air throughout the air column, and so you had all this ice everywhere instead of snow like you normally have um, in a colder environment. So yeah, it's been very very strange. Very mild December throughout the northern U.S. And much of the country. It's been very warm.
Mm-hmm. What do you think about the emergencies that might come up? Because there was a comment here from astrologer climate witness. She says, Nick, I think emergency management will be very busy in 2024. Do you have any predictions along those lines, Nick?
Well, I mean, there's always going to be disasters. I mean, one of the biggest problems are droughts and fires. I mean, that can crop up from droughts. You can get droughts in aridity and forested areas. You can get wildfires, and especially in areas where there's urban wildlife interface, you can get wildfires and threats to urban wildlife interface areas. You can get you can have problems with drought and water scarcity. You can have problems with um, heat, and I mean we saw that a couple of years ago with in the Pacific Northwest, where people are not acclimated to the heat or have the appropriate infrastructure to deal with the heat. So people end up suffering or dying in the heat. Um, so yeah, I mean, the El Nino is predicted to decline going into later spring and summer 2024. So hopefully, the effects of that normal climatic pattern will shift. But obviously, climate change continues, and so all the extremes related to climate change, climate chaos will continue, and so we're still going to be having to deal with everything that is associated with that. More disasters and catastrophes will be coming down the pipe from that. So
Mm-hmm. No doubt. No doubt. Tony, I was wondering if you had some thoughts of wisdom here to add to the general pot about how 2023 turned out and where we might be going in 2024.
Yeah, I think generally 2023 is a pit stop on this highway to hell, so to speak. Um, um,
Jesus. Yeah.
so, but I think if I had to make an estimate that we are going to hit right up below the 1.5 degree Celsius guardrail this year, I think temperatures certainly are going to come in between 1.3 and possibly as high as 1.4 degrees Celsius above the 1880 baseline. So that's quite alarming, and it shows quite directly that we're on a pathway of accelerated warming and disastrous warming. And we've
Hmm.
seen certainly throughout 2023 some of the implications of that around the world in terms of severe weather and climate disturbances. Just here locally, I've completely abandoned the hope of seeing any type of snow around Christmas around here in
Mm.
Winston-Salem, North Carolina. It was almost 60 degrees, 60 plus on Christmas for us. So,
Oh,
uh,
really? Oh, my
yeah.
goodness.
So those ideas are becoming increasingly far fetched. Um, but yeah, well, I suspect that 2023, like I say, is a pit stop on this road, and we'll continue to go burrowing down at an accelerated rate.
And the accelerated rate is just something that gives us cause for pause or something like that. So I just want to talk about how quickly this is happening. So let's turn our minds back to a time when humanity was not here, the time of the dinosaurs, the time of that asteroid that was 56 million years ago. The geologic turmoil added carbon dioxide to the atmosphere in quantities comparable to what humans are adding today. Temperatures jumped, the oceans grew acidic, species died en masse. But the big difference between what happened 56 million years ago with the dinosaurs and now is it took about 3,000 to 5,000 years to get there in terms of all of the emissions. And now we're doing it in just a couple of centuries. So that is just incredible. We are adding carbon dioxide to the atmosphere probably 100 times faster than had happened in the past, in extinctions from the past. So that means things are going to happen much more quickly. It also means there's more momentum in this change, and it could become more violent because once you start that ball going down the hill, it goes faster and faster. And that's what's happening to us now. And it's so fast that we can even see it. You shouldn't be able to detect these changes within any given human lifetime, but we see the changes here year to year to year. And that is a stunner. So
If I may, there's
please.
a couple things I want to pick up on what Nick and Tony said. Nick was mentioning about the extreme ocean temperatures. We'll be talking about that in a bit. But when you have the the temperatures, the sea surface temperatures, 5 standard deviations above the mean, that's in statistical terms, that's just like unheard of. I mean, because usually, plus or minus 3 standard deviation accounts for the entire data set, just about. And here we are, 5 standard deviations above, showing you how extremely warm the oceans are. And the other thing to keep in mind is the Mediterranean was really, really warm. And the Mediterranean the uh, is the source water for what becomes the North Atlantic Intermediate Water, which goes through Fram into the Arctic Ocean. So, as the Mediterranean warms, that warming water makes its way into the Arctic Ocean, doing all sorts of crazy things that we see up there with the Atlantification, the loss of sea ice, and so forth. As to the 1.5, 86 days this year, 1.5 has been breached worldwide. So we're getting there. It's just a matter. It's a matter of, at what point does it become, like, say, more than half the year? Don't know,
Mm.
but it's getting there. And we talk about the acceleration getting out of control. Well, I've been kind of tongue in cheek saying it, but it's really is happening. I've been saying, let the tetration begin. Tetration is rapid exponentiation. Like, multiplication is rapid addition, and exponentiation is rapid multiplication. Tetration is rapid exponentiation, and we're seeing that.
Wow. 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 Runaway exponentiation does not sound good. Does not bode
Mhm.
well for our planet.
No.
Um, Tony or Nick, do you guys have any response to that? What Jim just said about the rapid? What was that word, Jim? Tetration.
Think of titration chemical in chemistry, but replace
Yeah.
the I with an E. So it's
Tetration.
like tetra, the
Yeah.
prefix for tetration, and then add a tion on it.
Oh,
Tetration.
okay. Well, Nick and Tony, what do you think about the rapid titration of the climate?
Uh, no comments.
It's happening. All right.
uh,
Yeah.
yeah.
So,
Yeah. Yeah.
yeah.
Well, I was just gonna just say, yeah, I completely see it manifesting in a lot of the things that we were talking about earlier in our experience in 2023, and I'm sure we'll continue to see manifest throughout 2024 as well.
Yeah.
Oh, yeah. I think so too. Guys, let's just take a quick look about where we've been in 2023. There was an article that came out in climate.gov just yesterday, Climate Highlights of 2023. This has some incredible graphics with it. So, the first thing was we started off the year in January with heavy, heavy rains. I don't know if we can all remember back that far across part of the U.S. West. This was an atmospheric river, and it really accelerated um, over a 30-day period, up to 300% of normal in California. I think this is when Death Valley may have flooded. Nevada, Colorado, parts of looks like Nebraska, maybe Kansas as well. But there was just basically a huge atmospheric river. Oh, yeah, you're showing it there, Sandy. Everything that's green just got deluged in January for 30 days. It's pretty darn amazing. So that happened. There were feet of rain and snow across California and other parts of the West Coast. And of course, this helped out places that were in drought, also flooded places. So that happened. Another thing that happened is the polar vortex, which there's an animation of this, Sandy. Yep, you've got it. Kind of slipped off mid center. So it should be pretty well centered over the North Pole, but it slipped off over towards Svalbard. And I'm not exactly sure what caused it to slip over, but that it shows that, okay, here we are. The polar vortex began making headlines following sudden stratospheric warming. There was a sudden stratospheric warming event. Wow, pretty amazing. So those sudden stratospheric warming events are pretty notable. Does anybody here know about those sudden stratospheric warming events? Let's
I
move
know a
on.
li- I
You
know a
do?
little bit about them, but yeah, I'm not a stratosphere guy. It's not really my area of expertise. um,
Yeah.
but I know the warming events can cause the tropospheric polar vortex to split, and sometimes you can get cold air intrusions to then occur in parts of North America and Europe. And in fact, right now there is actually a warming event going on in the stratosphere over the pole, North Pole, right now. And so some people are wondering if we'll have another polar vortex split sometime later in January or early February, but nobody really knows if that's going to happen. So it's happening right now, the stratospheric warming event. So you sometimes see it a lot in late December, early January. You get those kind of events.
Yeah,
Um,
totally.
hmm
Totally.
hmm
What generally happens from
Tied
my yes, please.
Yeah, tied into exactly what Nick was just saying is that there is also now the Arctic dipole, which we have these definitely two distinct atmospheric cells that they kind of play this tug of war match over the North Pole between the Eurasian side and the North American side. A high and low pressure system, and it appears that what's going on in the stratosphere is impacting that, and therefore impacting how the polar vortex gets displaced about and moved around.
Mhm.
hmm
Yeah. Yeah, for sure. Um, Other things that happened, of course, we are in El Nino now, officially as of March. And this graphic here that Sandy is showing shows the progress of the El Nino from December to May. So this is a 6 month snapshot, and that rectangle right in the middle there across the equator, that's
Mm.
kind of X marks the spot. And you can see the leaving of the La Nina starts out in December. The La Nina is still in evidence, the cooler anomaly. And then you can see the warmer anomaly. By March, that warmer water has replaced the colder water. And interestingly enough, see where the Galapagos Islands are? Right there, kind of right beside Peru, just to the west of Peru, they're getting totally fried. I've heard some things about how the sea life in the Galapagos Islands have gotten very very affected by this. Have you guys heard about any of this stuff? Poor
Mm.
Galapagos. Because the El Nino heat is just completely mashing them. So the El Nino heat is going to bring a lot of heat into the atmosphere. So we said goodbye to La Nina, and in June we said hello to El Nino. So says one thing is certain: El Nino is here, and there is more than a 50% chance that it will end up historically strong, potentially ranking in the top 5 on record. And so they're going to continue to monitor this year's El Nino and bring updates in this blog here. Now, the next thing is the record warmth that we have been talking about pretty much, I would say, since May or June. It's been just so notable, especially in the North Atlantic. But this September global temperatures compared to the average. So this is a September global temperature reading, 1 bar per year. And you can see this graphic goes all the way back to 1850. So 173 years worth of data. Check out that bar that is 2023 on the very right hand side. It says hottest September on record. 1.44 degrees C was the average above for the month of September this year. It's kind of amazing. Um, do you guys want to talk about the record warmth that we have seen in 2023, most notably in September?
I guess I can start it off. Well, we're seeing the ocean heat that's been accumulating for basically 53 years or so. Um, that has led to an increased stratification in the ocean, thereby diminishing the ocean's ability to sequester that heat down to depth. So the heat's being trapped in the upper layers, and physics, thermodynamics informs us that it's going to move about. It can move horizontally, so it can move, uh, say to the polar regions and interact with the ice. It can move to depth, but that's slowing down, or it can move to the atmosphere. And uh, we're seeing the results of it moving to the atmosphere. I just saw some recent studies where they're measuring some flux rates of ocean heat to the atmosphere, and the results, as the researchers write, came as a surprise. In other words, it was more than they had anticipated. So we are seeing that that ocean heat, of course, helps hurricanes become very, very strong very, very quickly. It also, when you put all the heat, of course, you're going to get more moisture. You get the precipitation bombs, you get the flooding, etc. So we all know what's going on. So this, I can't say I am surprised, because I've been kind of, I guess, ringing the clarion bell that this is going to be happening. But um, the other thing keep in mind is that when you look at the, whatever the levels of CO2 equivalent in the atmosphere, there's a lag effect from when a warming molecule goes into the atmosphere to when that molecule, its effect is noticed. And that lag is about a 15-20 year period. So
Mhm.
what we're experiencing today is really due to the CO2 equivalent level of, like, say, turn of the century. So if you want to know what the effects of today's level is going to be, wait 20 years.
Mm.
I'll be gone by then, but wait 20 years.
It's true. And that, you have to keep all these different factors in your mind, but that lag effect of between when the CO2 is emitted and when it's actually felt, of 15 to 20 years. I mean, that just, even if things were to change, I mean, yeah, it's so depressing, right? Because when we had COVID, things actually did change, but it didn't change the temperature, right? I mean, CO2 kept going up still. So I don't know if there's a feedback that's going on. I mean, what do you think about that? Because remember, for the longest time when we were all basically staying home, nobody was driving, no one was going anywhere, and CO2 did kind of go down, but the temperature didn't. Does anyone have any comment about that?
It's thermal inertia. Is what it is. Um,
Yeah.
with, so there's a phrase for it called pipeline warming. Think about, when you're running the hot water, right, coming out of your
Hmm.
faucet, and then you switch to the cold side. Still, hot water comes out for a little bit.
Yeah, that's true. That's
So
true.
it's a very simple analogy, probably not the best analogy, but that's one way to think of it.
Yeah. And also the fact of the CO2 lag, even if the CO2 does go down for that moment, you won't see the difference really
Yeah,
because you're
Right.
still
yeah,
kind of like,
And really, again, what's the determiner of global average temperature is not the CO2 emission rate, but the accumulated CO2 in the atmosphere. So,
Right.
so that
yeah.
that's really what's causing the temperature. So even if there was a pause in emission,
mhm.
you still have that accumulated CO2 that's actually forcing the temperature upward. So, and I think probably what happened during the pandemic, you saw the pictures like I did, skies across Mumbai, Los Angeles, Shanghai, Frankfurt, London, much clearer. And
Right.
because the skies were much clearer, a lot more energy, solar radiation, was hitting the surface of the planet, thereby being absorbed by the planet. And as Jim stated, so we probably are seeing some thermal inertia related to that episode, that period.
Yes,
Well,
definitely. Hey,
yeah.
Jim, do you want to take us through your articles here? You've got your PDF here, another year in record heat for the oceans.
Okay. I'm going to have to put on my little optical assisters here, but anyway. Happen to get old. Okay, I'm going to pull it up on my side here so I can see this. This is a research paper by Lijin Cheng et al. A whole pile of researchers here, and they go around measuring ocean heat. That's what they go and do. Obviously, I'm not going to go through the entire paper. I can, I might hit a few points from the abstract. Uh, changes in ocean heat content, OHC, salinity, and stratification provide, and the key word stratification, provide critical indicators for changes in Earth's energy and water cycles. These cycles have been profoundly above due to the uh, let's see, I got to zoom in on this. Due to the emission of greenhouse gases and other anthropogenic substances by human activities, driving pervasive changes in Earth's climate system. And they go on to say that y- uh, the ocean heat from 0 to 2,000 meters in 2022 exceeded that of 2021 by basically 11 plus or minus 8.3 zettajoules. That's just in 1 year alone. Among the 7 regions, 4 basins, the North Pacific, North Atlantic, Mediterranean, Southern Oceans, recorded their highest ocean heat content since the 1950s. The salinity contrast index, a quantification of salty gets saltier, fresh gets fresher pattern, also reached its highest level on record in 2022, implying continued amplification of the global hydrological cycle. And so what they're getting at is that there's most likely increased evaporation. And if you increase evaporation rates, you are removing fresh water from the oceans, but you still have the same amount of salt. So you now have the same amount of salt, but in less volume. So the salinity goes up, and
Hmm.
hence the salty gets saltier. And of course, we know what happens when all that moisture goes into the atmosphere. So we're seeing ocean heat increasing dramatically. And if you can scroll down to figure one, this is kind of this has become an extremely familiar diagram to those of us who follow this, and and you can see how the ocean just, to make the analogy of what Tony just said about the CO2 accumulation in the atmosphere and the ramifications of that. Well, we can see the accumulation of the heat energy in the ocean starting in basically the mid 1990s. And I continue to make the argument that that is when the planet overall went past this tipping point. Once the oceans are no longer able to sequester that heat to depth, this is when things start going crazy and toss in the lag effect, and we are where we are now. So it's really not looking all that good. And let's see. So figure, I got to zoom in. Figure two shows the monthly line, annual, which are bars, changes in uh, the SC index and the stratification in the upper 2,000 meters of the ocean from 1958 to September 2022. And what we are seeing is basically where it gets into the orange, that's increasing stratification. So it basically mirrors the ocean heat content,
Mhm.
which is an expected result, to be quite
Yeah.
honest. But
Sandy, I
we
think
actually,
if you go down to the next picture where it's the orange one, just keep scrolling down. There you go. That's it.
yeah, it
We're
has
with
like
you now.
the green bars
Yep.
below the mean and the orange above it. The orange is indicating increasing stratification. The green, meaning less stratification, means more mixing of the more vertical mixing of the water column. So now we have increasing
Huh.
stratification. The heat is trapped in the upper layers, but with the increased stratification, you're not getting the vertical mixing to bring in the necessary nutrients for the phytoplanktons to do their thing.
Right.
So
So this
net
will
primary
result
productivity
in
is dropping off.
so this could
I'm
result
sorry?
in the krill. This could result in the krill dropping off the phytoplankton,
Yes, exactly.
which is the basis of the food web, right?
In the For the Southern Ocean, absolutely,
Yeah.
absolutely. And the other thing to keep in mind is, as you know, AMOC slows down. Okay, AMOC eventually, in its route southward, upwells in the Southern Ocean. In fact, it upwells in a region called the Antarctic Divergence. As it upwells, it nutrients, brings up nutrients that drives the phytos. You get the krill, you get the baleen whales, you get the orcas, etc., etc. Well, if AMOC is slowing down, that means eventually that upwelling will slow down. And if that upwelling, and when that upwelling slows down, it won't be upwelling the nutrients. That will have devastating impacts on the Southern Ocean.
And throw into that also, Jim, the melting of the ice in the Arctic and in the Antarctic. When you melt all that ice that is on Antarctica and also on Greenland and dump it into the water, what is that going to do to our ocean currents?
Well, that's what we're trying to find out. First of all, you're introducing what's called a freshwater lens. So there's an extra stratification, albeit a shallow one, but still it's a stratification. Now, stratification is a two-edged sword, like clouds are. The bottom of clouds trap heat, the top of the clouds reflect heat. So stratification is necessary to lock in the nutrients for the phytos to do their thing. But perpetual stratification is bad because the nutrients get used up, and without injection of new nutrients, you're not going to have productivity, which is why you look right on the equator, you're not going to see much productivity in the oceans there because you have pretty much a permanent thermocline year round. So you're not going to get that mixing. So, but with the dumping of fresh water, yeah, it's going to disrupt, especially vertical currents. And we're seeing signs that some of the horizontal currents are being disrupted because the currents are not able to as consistently maintain what's called geostrophic flow. That's just a way to balance a whole, vorticity and Coriolis and pressure gradients, all sorts of crazy stuff. But it will start impacting ocean movement, be it vertical, horizontal.
Yeah. Wow. Pretty darned amazing. And I've been kind of monitoring the comments that have been going on here. And Andy the gardener has said many times, The denialism of overpopulation, it's the elephant in the room. And I know we don't mention it here on this show too often, but I really think that we have to actually acknowledge that we are in a state of overpopulation and ever expanding population. It's not slowing down in the slightest. We're already 8 billion humans on the earth and counting. And does anyone feel like taking a stab at this problem of overpopulation? Any takers between the three of you?
Uh, well, I will say I think the impact that our humanity has the most is not necessarily the number of us, but what that number of us are doing. Certainly, different populations put different pressures on their environments. Um, and so, actually, you could have a population that's 1 billion people, but if those 1 billion people lived like Jeff Bezos or Elon Musk, they would be taking a larger toll on the planet than the 8 billion today. And we know this because we actually find studies all the time that recount this. You know, almost 90% of the fossil fuels that are emitted into the atmosphere come from just about 100 companies. We know that by far the top 10% of the affluent materialized population is responsible for the lion's share of emissions. We break that down into countries: the United States, Western Europe, Japan, now China. So it's clear that what we have to highlight is not just the number of people who are on the planet, which of course is a significant variable, but what those populations are doing, how those populations live, because depending on how they live, they'll accumulate more demands on their environment. And I think that's a crucial factor, is how affluenzic a population might be.
Mm.
Well, what Tony says is accurate and correct to a point. You have to still go back to Ecology 101, which is what's the definition of an appropriate level of numbers of a species. And namely, I'm talking about the carrying capacity, which is the number of individuals of a species an ecosystem can support based on available resources that can be renewed. And the problem is we are outstripping the resources faster than they can be renewed. And we're not even talking, putting aside the ever increasing demand for energy, putting that aside, just simply like, there's a huge number of people that rely on the oceans for their protein source. More and more people, more and more fishing, you're overfishing, you not given a chance for the year class strengths to renew the population numbers, and you're just going to strip the oceans bare. And we're seeing that. We're seeing that. We're seeing collapse of fisheries and so forth. It's interesting to note that population biologists who kind of look at this stuff here, depending on what paper you read, and I did a video on it, doing a review on these guys here. I seen estimates from as low as what the appropriate carrying capacity is, from as low as 20 million people up to 1 billion people, with a median, with a median of between 100 to 600 million. Well, depending which number you want to choose, 100 or 600, we're at 8 billion. That's still it's
Yeah.
still much higher than than what they're suggesting is a sustainable level.
Yeah. No, overpopulation is a huge, huge deal. No
It
kidding,
is.
right?
It is. I think, I think the next interesting, going back to this Cheng paper, if we can scroll down to figure 3, and that just shows the annual ocean heat content anomaly compared to
There you go.
1981 to 2010
Yeah.
baseline. And as you can see, the red is it's more, and,
So
and this
explain
is
to
from
us
0 to
who are
2,000
looking at the
meter.
screen. So the top one is what, and the bottom one is what of those two that we're looking at on the screen?
Okay. Are you on figure 3? There should be like 3 little panels there on figure
Yeah,
3.
but the third one we can't see because Sandy's got it covered up.
Oh, okay. Well, if we start at the top, A says the 2022 ocean heat content, 0 to 2,000 meters anomaly relative to 81 to 2010 baseline, and it's given in 10 to the ninth joules per square meter. And so obviously, the redder it is, the greater the anomaly, the greater the ocean heat relative to that 30-year period. And what they're really doing is they're looking at, let's see, it might be different times of the year. I'm trying to
Are they?
remember.
The bottom one
Yeah,
is very spotty, that I can see. It has lots more
yeah.
spots. The other ones are very kind of wavy.
Okay, the middle one is relative to 2021 alone, and
Oh,
then
really?
yes, and then uh, the second one as well. It's so the middle and the bottom are relative to 2021, and then the top one is relative to the 30-year baseline. So the
Okay.
top one, think of it as the cumulative relative to that 30-year period, and then the bottom two just basically the change in from one year to the next.
Oh, okay.
So that's what's being shown there. In essence, it's showing that the ocean is continuing to uh, absorb heat energy, and I'm in the middle of looking at a really fascinating paper that examines the role of mesoscale eddies in the ability to take the atmospheric heat and drive it into the oceans. So it looks like a so I'm still in the middle of digesting it and tearing it apart and studying it.
Hmm. So mesoscale, I assume that is not a Japanese soup.
Yeah. No, it is not, unfortunately.
It's my next cat's name. Mesoscale Eddie. Come here, kitty kitty.
Oh yeah,
they're
there you
they're
go.
little gyres of about a couple of tens of kilometers to maybe a couple hundred kilometers in diameter. For example,
Wow.
if you look at representations of the Gulf Stream, you see all these little twirly thingies that pinch off the Gulf
Sure.
Stream. Those are all mesoscale eddies.
Oh,
Oh, okay.
okay. Interesting. Well, do you want to take us through the climate change ocean heat content from climate.gov, Jim?
Sure, sure. Let's move on to that. Uh, oops, I did the wrong thing there. Hang on. There we go. That's the button I wanted to hit. Okay, there
And,
we
and,
go.
and Nick and Antonio, jump in if you have other things to say. I just couldn't think of all the questions to
This one,
ask.
Jen?
The
So
climate.gov, Sandy.
the climate change, the one, the climate.gov climate change ocean heat content is Jim's article.
Gotcha.
Okay.
Well, well, I'll take you through the highlights there, and then we can just look at some of the diagrams there. The ocean is storing an estimated 91% of the excess heat energy trapped in the Earth's climate system. Average over the full depth of the oceans, 1993 to 2022 heat gain rates are approximately 0.64 to 0.83 watts per square meter averaged over the surface of the Earth. So earlier, we were discussing it, or briefly touched upon Earth energy imbalance, and everyone's measuring the watts per square meter. And a lot of the people who look at this are neglecting the ocean. Well, we just have this value here of basically 0.64 to 0.83 watts per square meter. That's in water. Remember, the specific heat of water is much, much higher than that for the atmosphere. So to, you just need a chunk load more energy to heat up the same amount of water versus a similar amount of air. Increasing ocean heat content is contributing to sea level rise, ocean heat waves, coral bleaching, melting of ocean terminating glaciers, and ice sheets around Greenland and Antarctica. And we've been discussing this for how many years? Heat already stored in the deeper layers of the ocean will eventually be released, committing Earth to at least some additional surface warming in the future. And when you factor in increased stratification, the heat that's in the upper 0 to 500, 700 meters, which accounts for about 68% of all this heat gain, that will readily be released, if not all of it, a good portion of it back to the atmosphere. So, figure uh, the first figure there, ocean heat compared to the average. Well, this is now all too familiar to us. And this is in 10 to the 22 joules. A zettajoule is 10 to the 21. So you can add a zero to each of the numbers on the scale and then change that to zettajoules for your scaling, whatever. But you can just see the accumulation of the heat. And the next figure down, ocean heat trends, except for a couple little patches in the North Atlantic, you know, down in the Southern Ocean, and by the interestingly enough, the Kuroshio current in the Western Pacific, the oceans are warming up. The overall trend is it's warming up, and the change is given in terms of watts per square meter. And if we scroll down to it says change over time, we have some graphics that shows the ocean heat compared to 1993 average from 1993 to 2019, and we see what and this is given in, looks like what's it, 10 to the 21 joules, so it's given in zettajoules, and the trend is unmistakable. The trend is increasing. Now they break this down into the orangey and red lines are for the surface, the 2,300 feet, the same feet now. So
Mm-hmm.
basically 700 meters. Okay. So 0 to
Mm-hmm.
700 meters. And then from 700 meters down to 2,000 meters is the blue. And then the gray is the abysmal, uh, you know, section of the ocean. It's very, very deep. We're talking like Marianas Trench kind of stuff. And it goes to show when you're looking at that, you can the
Uh,
ocean heat has still even reached the deepest portions of the oceans.
Mm-hmm.
and that's
Yeah.
incredible because, of course, we know that no sunlight reaches the bottom of the ocean. Actually, I mean, you know more about this than me, Jim, but after a certain level, no sunlight reaches past in the ocean. So the fact that, this is a place that you would think would be relatively undisturbed. But I guess we're finding out more and more that we not only are we impacting the bottom of the ocean with our plastic, but we're also impacting the bottom of the ocean with our energy exhaust from our civilization. So that's incredible.
You're absolutely right that the sunlight energy you know, in the tropics, let's start there, where it's very clear, you'd have poor productivity water, so the waters are very crystal clear. Sunlight energy may penetrate 100 meters, 150 meters, maybe right on, summer solstice as such, and get down to 200 meters. That's it, maybe. You start getting into the North Atlantic, 10 meters if you're lucky. You know, so sunlight energy does not penetrate that greatly, and when it does, there's a very quick attenuation of it through the water column. It's an exponential decay function. So um, this is where again the role of the mesoscale eddies seems to be playing an important role. So I will be reporting to you guys when I finally get around to making that video, but it's a pretty detailed paper, but so stay tuned on that aspect. But that graph right there tells me just how much energy is in there, and remember the specific heat content. Water is so much higher than air. So, and of course, it takes longer for the oceans to warm up. It takes a lot longer for it to cool down.
Right, right. Yeah. So we can see the surface layers are heating up quickly, but also the ones that are deeper in the blue and, of course, even the gray. So the ocean is heating up a lot, and that's going to change everything, right, Jim?
It is, and we're seeing it.
Yeah. All
Um,
right. Thank you for that.
I'm done blathering. Let someone else talk.
Oh, okay.
I've
All
already
right.
shot my mouth off enough tonight.
Okay. Well, guys, let's go over to this Copernicus. Tony and Nick, I don't know if you have that Copernicus article up that I put into the chat yesterday or today. But Copernicus article, November 2023, remarkable year continues with warmest boreal autumn. 2023 will be the warmest year on record. And the very first one, this black graph that says global surface air temperature anomalies, you can just see 2023 is not like the other years, not even remotely. It's cutting its own path completely. And Nick and Antonia, would you guys like to weigh in on this graph and comment about 2023 and maybe talk about some of the reasons why you think that 2023 might be as big as it is? Everybody's trying to figure it out.
well, I certainly do think it has to. The El Nino has a large role to play in the discrepancy that we're seeing between 2023 and the other years. Um, and then also 2023. I mean, as we're going along, this could have been 2016, back in 2016, right? So while this graph does look unique, it looks unique as time continues to go forward. But I'm positive, unfortunately,
Mhm.
that when we look back at this graph in the next several years, it will look less unique.
Mhm.
But the contributing factors, as stated before, I do think that we could be potentially getting some latent heat from the COVID, the slowdowns in the economies. Um, Jim was talking about earlier the change in sulfur dioxide emission from large cargo shipping would certainly have play a role in the amount of energy that's allowed to hit the surface. Um, and then generally, we are seeing the planet warm. So we should expect that a confluence of variables are certainly going to contribute to that spike in temperature that we're seeing this year, in my view.
Mhm. Yeah. What about you, Nick? What do you think of 2023 so far?
Nick, I think you're muted.
Okay, thank you. Yeah, I agree with everything Antonio said. I mean, basically, 2023 had a big convergence of different factors that came together to make it such an exceptional year. And everything, from El Nino um, to the aerosol masking stuff to the just just the acceleration in global warming, oceans releasing so much more heat, just everything coming together. And I also agree um, um, that in several years, that 2023 probably is not going to seem as exceptional as it seems now. Like 2016, 2015, 2014. Those years seem so crazy back in the day. Now they seem like a distant memory now compared to 2023. Now it might be 2026, 2028, 2030 that might be the exceptional year, and 2023 might seem like a distant memory. It's this acceleration and this acceleration in global warming, and it's continuing to occur, that makes um, the past seem um, less powerful than it seems in the moment. But of course, the events, the disasters, the impacts on the people and the environment, all those are of course bad for everyone and everything, um, no matter what. But yeah, 2023 was absolutely crazy in terms of everything that we had to deal with, from all the flooding rains, the exceptional heat waves in different parts of the world, the floods we saw in Libya. We had an exceptional hurricane that hit Acapulco and caused
Hmm.
devastation there. Yeah, it's everything that happened. Yeah, very very wild year that I'm sure we
Yeah.
won't will not miss.
Yes. And Sandy, yeah, keep going down to that next graph. That one, yeah, perfect. This graph that you see, we're in Copernicus. The global surface air temperature anomalies for November from 1940 to present 2023. Look at this. It is 0.85 degrees C up from the 30-year average, the most current 30-year average of 1991 to 2020. You take that 30 years, average it out, that's the blue line. Look what has happened. It is just soaring at this point. It is not even remotely close to any of the other years. And that's 2023 right there in a nutshell. It's kind of amazing. And it's the same on the next graph down to Sandy, the daily global surface air temperature anomaly. So this is the air. And again, you can see this is basically from the 1940s, which are blue, to 2023, which is bright red. And this thing is just off the charts, literally. So, yeah, welcome to planet Earth. This is really rough stuff.
So, guys, what's your prognostications for 2024?
Oh, I think 2024 is going to be brutal. I think El Nino is going to blossom completely. And as you know, we have cut down in the sulfur dioxide in the shipping fuel and various things like that. There's going to be the global cooling because there's going to be less particulation in the atmosphere. Usually you would think that less pollution is a good thing, but sometimes it is and sometimes it's not. And yeah, so, you know, there's just a lot more heat. There's a lot more polluting greenhouse gases and a lot more people. And El Nino is taking off. And I don't know about the solar cycle. Is the solar cycle taking off as well? Does anybody know?
Well, the aurora
Anyway,
activities are increased, so yeah.
yeah. So there you go, guys. I think 2024 is going to be a mess from a climate perspective.
Tony, I thought maybe you'd want to fill us in a little bit on what you might have discovered in COP28.
Yeah, so the ongoing conference of party process, the response to the ongoing crisis that we just talked about in detail tonight, what our governments are doing. In case you don't know, we have had our 28 conference of parties in Dubai, which is a kind of oil hegemon in the Middle East. The president of the conference of the party was Sultan El Jabbar. Um, Sultan Al Jabbar is also the president, the CEO of the Abu Dhabi National Oil Company. So that tells you a lot about the nature of this particular conference and why there was so much environmental activism um, surrounding the conference. Of course, this conference, there was over um, 2,500 oil company uh, lobbyists outnumbering the political delegates from all countries except one. So that also tells you a little bit about the nature of how this is coming down. But some of the big takeaways, of course, was around the financing around the loss and damages fund. This is a fund that's been speculated throughout the climate process. The idea of this fund is as the damages from climate change continue to accumulate around the world, that there will be a fund that is meant to finance a lot of the first aid response and redevelopment and settlement plans that countries would have to negotiate as they're dealing with the climate crises. So far, this plan has a funding of somewhere between $300 and $500 million, uh, which is really just pennies on the dollars for really what would be coming in the future. The United States, of course, put forth only $17 million to the fund. Uh, Secretary of State Antony said the United States is planning to put $150 million toward another fund to support crop resistant or drought resistant crops, GMOs, as a response to dealing with climate change. Um, Now, while I think there might be some good in doing things like that, certainly the host of calamities that face the food supply across the world go well beyond just being drought resistant. Just as Jennifer was going over with some of the deluges that we've seen in the western United States, drought resistance wouldn't help you there. So that's just one of the problems. Or if you're in Canada and you're dealing with historic wildfire, again, being drought resistant won't necessarily help. Um, but yes, that's what's going on at the that's what was going on at the conference of party is the settlement of this loss and damage fund. How much money are we going to contribute to that over the years? How seriously are we going to be taking that movement as we start to realize the damages and the consequences of living on a climate change planet? So for me, that was the major takeaway from the conference of parties is how we're going to start dealing with these damages as we start to accumulate them. And so far, again, the fund is only the fund doesn't have 300,000 to 500,000 $500 million. The problem with it is that those are the pledges that the fund will have. So we're wait to see those monies materialize.
It certainly is something what happened there. It really is. It really is. So where
So
would you?
I
Yeah.
I,
Go
I
ahead.
have a little bit of a comic relief here. Obsolete optics, thank you very much. Scientists are mystified, baffled, puzzled, stumped, curious, perplexed, alarmed, shocked, appalled, confused, stunned, horrified, clueless, worried, terrified, frustrated, scared, concerned, and bewildered. Any comments about the scientist's befuddlement?
My only comment is don't look up.
No kidding, right?
It gets a
Well,
flush, but it was good.
Well, sometimes you do need to look up because you never know when a raven is flying over you, making a dumping run on you.
Oh my God. Has that ever happened to you? It happened to me.
Yeah, it has.
Have you ever got shot upon by a bird, like mid-flight?
Oh yeah, I've
It
actually seen
happened to me. I
ravens.
was walking along the street when I was like 19 years old, and I will never forget it, and a pigeon or something flew over and it hit me right here and it went right down my nose and flipped off. It's like, oh my God.
Wow.
It has happened to me numerous times, and what's
Oh,
interesting
wow.
is that you actually see. You actually, they must just hate me. Hey, there's the gym. Let's go shit on him. But anyway,
Yeah, okay.
but I've actually seen them. They're in flight and they see me. They go, oh, and they actually change their direction so they can aim at me.
Yeah, there you go.
Like little World War II bombers.
Yeah, and they come in, and then you actually see it leave their ass, and you have to step aside. So,
Horrible.
Bombs away, Jim. Bombs away.
yeah, no kidding, no shit. But anyway.
Right. No shit.
We have a couple of questions. I have the first question from Bim Jim was earlier. The AMOC is what % of the global conveyor belt?
Well, the conveyor belt, as it's colloquially called, kind of starts in the North Atlantic. There's also another entry point for the conveyor belt, and that is off Antarctica. You have a deep water formation off Antarctica as well. And I can mention this now to Jennifer's question early on about how the addition of fresh water from Antarctica impacts water flow. That will impact the deep water formation off Antarctica, because usually what happens when AMOC slows, the Antarctic deep water flows far north to replace the North Atlantic deep water, because you have to have this thing called continuity or conservation of volume in the oceans. And so what's going to happen is if Antarctic deep water slows down and AMOC slows down, you're not going to have any movement in the deep waters at all. You're going to end up having, basically stagnation. You're going to create hypoxic, possibly anoxic oceanic water layers.
Well, that's pretty scary, I'd say. All right, here's another one. How often do double El Ninos happen? How about you, Nick?
Well, they do happen. I mean, trying to think of the last time it happened. Maybe in the early 1990s, you had El Nino happen multiple years. I think in 1991, 92, 93, 94. I think you had a couple of multiple El Ninos.
Mm-hmm. Well, what about the
ago.
triple-headed La Nina we just got out of, right? If there can be a triple-headed La Nina, then there can be a triple-headed El Nino. And maybe that's what's going to happen right now.
Yeah, you never know. Yeah, we'll have to wait and see. Yeah.
Beware Cerebus.
Okay, and Mark made a comment. Hello, Mark. Solar is very active and very concerning to those concerned. So going back to Jennifer's question before about the solar and the radiation coming. All right, we have one more, I believe, and this is climate chaos. Any thoughts on Arctic permafrost loss rates?
Jennifer,
Well,
that's
I
kind of up
mean,
your
I guess I'll take a stab at it. I mean, the permafrost is thawing. I mean, there's no question about it. As it gets hotter, the permafrost thaws. It's just ice, you know. And so if the ice breaks out, then it's basically a self-reinforcing runaway feedback because it will emit methane as well as carbon dioxide. When it emits methane, methane's instantly heating. And it doesn't take 10 to 20 years to heat up. It heats up at the point of emission. And that's why you can see these kind of bright spots too. When you look into these temperature anomaly maps in the Arctic, you can see places of high methane emission. Methane can come out of rocks as well, you know. Up in Novaya Zemlya, where they had the biggest atomic bomb, they had a big Soviet atomic bomb site there, right? And was it for Zarbomba? Was that what it was
Zarbamba.
called?
Yeah.
Zarbomba in, I think it was 61 or something like that. And then if you look at Novaya Zemlya with that in mind, you can see, and they've seen coming out of the limestone croppings, you know, methane, pure geologic methane pouring out of those rock crops. And so, you know, combine that and then with the heat, I think the permafrost is just going to continue to thaw and more quickly as the atmosphere heats up. There have been some really anomalous heat events up in Canada, in particular, British Columbia, where it got up to nearly 120 degrees Fahrenheit. I mean, what's that going to do to the permafrost, right? It's just going to start caving away. Of course, all the infrastructure up there is
Yep.
going to cave in, all the pipes are going to cave in. Anything that's built on the permafrost is going to give way. The railroads are going to give way. All infrastructure in the Arctic that was built on the permafrost will
Yep.
give way. There's no stopping it, and it is a highly combustive situation, and you will have the permafrost fires that do not go out. So the permafrost is probably one of the very scariest climate things, just because it is the way it is, and it is so pervasive and huge. It's a giant, giant area, mostly Canada and Siberia, and of course Alaska, Jim. Alaska, we know. Um, you know, so that's just going to continue to thaw and degrade, and it will get faster and faster.
Here's another thing to consider and include is that as the Arctic is warming, precipitation patterns are changing. And studies have been shown now that the precipitation is coming more and more as rain, even into here in Alaska into October, November. We've This year we did now we got snow, yay! None of that freezing rain nonsense. But with the increased amount of precipitation that takes place, especially in interior Alaska, which until recently has been classified as semi-arid region, it's getting wetter. Well, you have more rain coming in. Rain is liquid, so that means it has a heat content higher than the freezing slash melting point there, right? It's hitting the ground and it's percolating into the ground and it's carrying that heat, the
Mm-hmm.
sensible heat with it, and it is further adding to the thawing of the permafrost.
Oh yeah.
Oh,
Oh
sure.
yeah.
Okay,
Tough
we've got.
stuff.
Oh, sorry.
No,
We've
no.
got Void. Hello, Drew. Has Jim read Natalia Shakova's new paper yet on the ESAS methane study? I think it's some new satellite technique.
I have not.
Oh
I will need
boy.
to. I will
That's
need to
going to be
look for it.
good. Yes.
Well, you all aware of the situation between Natalia and Igor? I mean, they're kind of trapped in Russia right now, so no emails in or out.
Boy.
Well, Drew, email me a link if you've got it to the paper, and we'll get it to Jim somehow. Okay. Truly aghast. Great name, right? Truly aghast. When I hear serious scientists say that there's still a chance we could stop this train wreck or at least minimize the impacts, should I believe them? Wow, that's a well, it's tough because people, want to.
I would say no.
I second it.
Guys,
I would say there's never a wrong time to do the right thing.
I
do
like
you
that.
think this are intentionally keeping us in the dark, or are they just dealing with their own psychological issues and they haven't been able to process this? And they have an extreme case of cognitive dissonance. What do you think?
Funding talks. Whoever funds them is a cynical take, but it's the reality.
All right. Well, let me see if there's any more questions. I think we've covered it. How do you feel, guys? Are we? We've been over an hour. Is there anything any of you want to cover that we haven't? Any loose ends? No loose ends. All right.
Um,
Go
I've got
ahead.
a couple. One thing we need to start looking at, and this is a serious problem, is what happens to agriculture, what happens to crop yields, and the nutritional content of whatever the yields are. 'Cause you hear people saying, "Whoa, more CO2, that's more plant food." Not really.
Oh,
Um, I just posted a video where the stomata on plants don't know what the hell to do. They don't know whether to open up and pull in the CO2 or to close down. Why would they want to close down? Because when they open up, transpiration occurs, water loss. If they stay open too long, they wilt. So this, you hear people saying, "Oh, more CO2 is more plant food." They're incorrect. They're just plain, don't get it. But we're, plants like any other organism have a preferred temperature range, and most of the crops that humans cultivate and grow and so on, their preferred temperature range is below 85 F. There's a couple like corn, the C4 plant, that can tolerate temperatures into the 100 to a point. So we're warming the planet. The crop yields are going down because it's just too damn hot for the plant. And whatever plants do survive, the nutritional content is lower than what it should be. And there are more and more studies coming out that are measuring all of this stuff. And this is a big, big concern. And you couple in with ever increasing population, we're not even able to make the food to feed everyone. And this is extremely concerning. Another thing to think about, we talked about earlier, oceans absorb 91, 93%, whatever, of the heat energy. That means the other 7 to 9% has done everything we've seen. Think about that. All the crazy stuff is done by the other 7 to 9%. So when that other 91, 93%, even if just say a quarter of that or half of that kicks into the atmosphere, hold on to your britches, boys and girls. It's going to be a ride.
Okay, we
it
have
doesn't
another
sound very
question.
good.
We have another question, and that is from Scott. Thank you for moderating tonight, Scott. Jim, do you have any opinion of the cause of the rogue wave that hit Ventura Beach?
Well,
Caused a lot of
if
problems.
whatever physical processes come together to create the ideal situation. It's no, seriously. I mean, that's rogue waves. We can describe it mathematically. We can describe the factors and so on that can create such a thing. But actually being able to say, "Hey, one's coming," we're not
Well,
there
that's
yet.
why they're called rogue waves, right?
Exactly.
Thank you, Vegematic. He said
Oh,
he
that's
said it's
wonderful.
Canadian money, so it's actually 25 cents. And Dog Dude, thank you also. That was very generous and lovely. And
Yeah,
I think it's been
I
a
thought the
great show.
exchange rate favored the Canadian dollar now. Anyway, but
It's been a while. I used to go to Canada to do that. All right, let me see if I can put myself back on with my does anybody, Nick, do you have a parting comment? Tell
No, no
anybody
parting.
anything you're doing, now to tell them to watch out for, that we can watch out for?
No, no, nothing going on. I'm working on my. I defended my dissertation proposal and successfully, and
That's great.
Yeah,
yeah,
cool.
congratulations.
Yeah, I
Good
mean
for
that's
you.
not
Yeah.
nothing going on. That's fantastic.
That's
yeah,
awesome, Nick.
yeah.
That's
I
a real milestone.
did that a couple weeks ago. I have to do some revisions to my proposal, and then I will start my research, and then yeah. Right now, I'm just exhausted because I just came back from a trip to help my mom with some stuff. She's in a rehab, doing rehab for a surgery that she had. So I'm hopeful that she'll recover from that and fully and over the next several weeks, and everything will be fine for her. But yeah, yeah, I'm hopeful to get going on my research and yeah, yeah. So
Good. All right. Well, how about you, Tony? Anything going on that you have that you want to share? Like
Yeah.
when you're taking over the channel? I
Well,
mean, it's a joke, but I'm not even like, I don't even get. Okay, I'm in my pajamas.
well, I gotta be able to stand on 2 feet first. So
I know, I
um,
know, I know.
I'm still recovering from that, but I am getting better, and I started walking without my boot today for the first time,
Yeah, we
and so
okay.
had we had an injured member of the party. Yeah, yeah.
so
Tell everybody what you did.
I was actually on vacation and I was playing pickleball, and when I was playing, I ended up rupturing my
Oh
left
my
Achilles
God.
tendon.
Yeah, that hurts.
Yeah,
I thought pickleball was supposed to be like more gentle or something.
yeah, that's
You
what they
you must
say.
be
That's
very
what.
Not for
competitive. You
Tony.
were slamming that thing,
Yeah, I
right?
was really getting into it. So,
Yeah.
Oh my
Boom.
God. All
Uh,
right.
so
Well, Jen, anything?
No, I mean, hang on. It's going to be a bumpy ride. I think 2024 is going to be pretty tough. I think it's going to be hotter than 2023. And, it's going to be the new normal. So, it's challenging because we're all fallible human beings and
Yep.
we're living our lives with all of our complications. And, some of us have aging parents, some of us have partners that are not doing well. And, we do all that. And then you pile climate change on top of that. This channel here is for the awakened to provide support for the people who understand what is going on because everybody needs support and companionship along this way because this is going to be rough, man. It's going to be rough.
Thanks, Jen. Jim?
um, well, just staying up here in good old Alaska. I've got
Minus 27 today on your walk.
yeah. If it was a balmy minus 27. Could have been minus 47. But anyway,
Ah. All
look on
right.
the bright
Well,
side.
I
But
will tell you, guys, I'll see you Tuesday night on my show all about overpopulation.
Uh-oh.
Everybody in the chat will. Okay, I'm definitely doing it. All right, guys. Well, thank you very much, everybody in the chat, and for the super chats, and the moderators, Kim, and everybody. Gary, thank you, thank you, thank you. We will be back. We will be back. We'll have another state of the planet, but right now we're just going to tune. What is it? Tune in, tune out, say goodbye,
Well,
and
uh,
what?
I
What?
want to take the opportunity to wish everyone happy and healthy New Year. And
Yes.
Yeah, Happy New
Yeah.
Year. I didn't even have a
Happy
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 New
New
New Year
Year.
Year,
song.
all.
All
We
right.
just
actually
Happy
made
New
it to
Year.
just that.
2024. How did that
Yeah,
happen?
I haven't even decided if I'm going to do anything for New Year's here. I'll let you guys know though. But thank you all. We love you, and I'm just going to play the out intro for the outro.